Hey everybody, welcome back to another training video. My name is Chris, and today we're going to be focusing on Conversational CAM Pro, and specifically on a dedicated toolpath known as turning round. Now there's a lot of different toolpaths in Conversational CAM Pro, also known as CeCam. This one, the turning round, I'm going to call it a core or foundational toolpath that you're going to be using. Almost guaranteed that you're going to be using this toolpath in almost every single spindle that you're going to program. Okay, it's also critical because this toolpath will be one of the first ones you implement into your actual part before other turning procedures, because they're going to be asking what turn round cylinder do you want to place these on. So this is what's going to perform the actual turning round sequence as the original process. Now, CeCam Pro in general doesn't have any visuals. In other words, you can't draw anything for CAD drawings, and it doesn't have a simulator. So I want to answer two questions in this video specifically. One is, what is this process and what does it do? And second is, how do we actually program to do that? Okay, so to help visualize what this process is and what it does, we're going to use two tools. We're going to use, first is the Aspire CAD software to help visualize in a 2D layout of what the part looks like and how the cutter is going to be approaching that part. We're also going to use that to give us parameters that we need that we can plug manually directly here into CeCam Pro. The last resource to help visualize this will be at the end of the video, where we're going to show and explain the cutting advantages that take place on the CNC machine. So we'll actually be able to physically see what the cutter does to the material and how it approaches it. And it will repeat those same processes and same advantages regardless of the length or size of the actual round cylinder you want to program for this turning round toolpath. So let's get started here by going to our Vectric software, and we're going to create a new file for the blank size that we want to produce. So I'm just going to do if we're looking at this as just from a side view or a top view, okay? And we're going to put in the blank size that we're going to be demonstrating for this particular video. So 18 inches long, 2 3/4 inches wide, and it really doesn't matter what the thickness is because I'm not going to be tool pathing any G-code from this software. We're going to do that in CeCam Pro. Also, it doesn't matter where I place my X and my Y, Z zeros for the exact same reasons. So this will work just fine for what we need. I just need to know the length and the width of the part to help visualize in a 2D setting. Okay. So let's now quickly draw some layout of general shapes of where we want turning to take place on the spindle. So let's say that the first 4 inches of this spindle are going to be used for a square section. Okay, so we're not going to turn that section. And let's do the exact same thing on the opposite side. So we'll just put another 4-inch square section here. And now we're going to draw a section in the middle between those that will be turned round. So this section here, we're going to make it a little bit smaller. Instead of just 2 3/4, let's make it actually 2.5 inches in diameter. And so we now, from a top view or side view, this represents a square section on the ends and a turning round section in the middle. So let's help visualize what the cutter is going to do to a square blank to get to this finished turned round diameter section. We're going to quickly just draw a cutter here. I'm going to draw a rectangle that represents the type of cutter we're going to be using throughout the sequence, known as a flat surfacing cutter. And let's give it a shank while we're at it. A 1/2 inch shank that's, it doesn't matter the length. And we'll just pop that in place. Okay, so with the cutter here, let's show you what this is going to do. So what's first is going to happen, the cutter is going to position itself, okay, at the starting position of the turning round sequence. In other words, this left-hand side of the turn round process. And it's going to actually start above the material where the corners are swinging. It's not going to just plunge into the material and start cutting. It's going to approach that diameter in a controlled manner. So it's going to start out here while the stock is rotating, and it's going to plunge down until it gets to the diameter section it needs to be. And then it's going to travel down the stock while the stock is rotating continually until it meets the other end. And once it gets here, it's also going to rotate to square off that corner and section and then lift up out of the material. And that's the tool path that's going to take place. Now this is going to take place in multiple passes, okay? Just so we're not taking too big a bite for the cutter, and that will happen automatically, and we'll see that when we go to cut this on the machine. But that is the actual sequence the cutter is going to travel for this process. So let's go back to Conversational CAM Pro and see what information we need to program how to make this process take place. So if we go here to our projects, and we're going to just create, I've already created a project here for training samples. I'm going to select that project, and in here under the turning workstation of the project, we're going to create a part. So this part, I'm going to make sure that we create a new part that matches. I'm going to call this the turning round sample part, and we'll make this the same size as what we just barely drew. So 18 inches long, 2.75 inches thick, and it is a 4-sided component going into the machine. Okay, this information is critical because this will automatically calculate what the corners are swinging. Okay, that swing diameter of those corners are automatically calculated for us, so it knows where to start cutting. Okay, so there's our part that we've created with the dimensions that we've put in place. Let's close this, and let's go now add some toolpaths to our blank here that is the turning round sample. So managing our toolpaths, and again, there's lots of different types of toolpaths here, but the one we're going to focus on today is turning and turning round. Again, this is a core toolpath that you're going to master really, really fast because it's going to be used everywhere. So if we add this to our toolpath list, and I'm going to push close, and that will show up here in our project tree under round, the turning round process. So if we click on this, this is now where we're going to be putting data into our toolpath questionnaire system so that it calculates and creates the right parameters for what we want to turn. So the first thing it's going to ask us is what tool do we want to use for this process? And we've kind of already answered that. If we click on this field, it's going to open up our tool database. And we're going to come down here to our surface planing cutter, and if we select the 1 1/4, which is our go-to for a majority of the time for most turning applications, it's a cutter from Magnate 2704, and it already has all the cutter information here. So that's the tool that we also visualized in the CAD/CAM software showing the toolpath sequence. So let's select that tool. We're going to assign this to tool number 1. It doesn't matter if it's auto tool change or manual tool change, we're just assigning it to tool number 1. And this is asking us, is this already being applied to a turned round section? Well, if we go back to our drawing here, if this was a square blank through and through, this would not already be turned round. So we can keep that question answered as no. Is this turned round? No. Now, what you're going to see is in each one of these toolpaths is you're going to have a question which is extremely abbreviated. For example, starting position. Well, what does that even mean if you've never done this before? You do have a help description here on the right-hand side, trying to define what a starting position actually means. I'm going to be the actual help today so we can understand exactly what these represent and where we're going to get these parameters. Okay, so we need to know a starting position, we need to know an ending position, and we need to know the diameter that we want to turn to as the finished diameter. Okay, so the starting position is what represents as the X position along the length of the turning from X0 to our starting point. The ending position is also along the X-axis from X0 to our ending point, and the diameter I think is pretty straightforward. What do we want to turn it to? So let's go back to our drawing file here, and we're going to add some dimensions. So we can just move our cutter out of the way or delete it altogether. It does not matter. And we're going to add some dimensions here right to our drawing. And from X0, so the edge of our part, I mean, most of the time in most turning applications is going to be the edge of the part. There are different situations and different fixtures where X0 could be shifted forward a certain amount, and you would want to measure from that new 0 position in the blank. But to keep things simple for you right now, I'm just going to say that X0 is the left edge of the turning blank, which is the headstock edge. Okay, so we're going to click on X0 and then go to where it starts turning round here along this edge, and we're going to do a horizontal dimension. Okay, so if we go here and do a horizontal dimension right there, so that is the starting position along the X-axis, and then from X0 to the ending point of the turned round section. That is the ending position along the x-axis. Okay, so that's starting and ending. Now we can do a vertical dimension, which is going to represent the diameter that we want to turn to here as the finished result, which is 2.5 inches in diameter. So these are the three numbers that we need to plug directly into this toolpath sequence to get the results that we're looking for. So let's go back to CeCam Pro. And so the starting position is 4 inches, the ending position is 14 inches, and the diameter is 2.5 inches. And again, we can check those: 4, 14, 2.5, 4, 14, 2.5. Okay, so we have all the correct numbers put into the right field in the right locations. The rest of this is pre-filled out for us. These are how fast it's cutting and how much material it's taking per pass for roughing and finish passes. We're going to see the roughing and finish passes taking place when we go to the machine and see and watch this. But we're not going to get into the details of how to modify these until later on. We'll do that in a separate video. Okay. The last thing I'd like to point out is that this is so far being programmed for a cylinder turning is what we're focusing on, just turning it around as a straight diameter across that cylinder. And so that's because this last question is this on a taper, yes or no? And no, if it's not a taper, it's a cylinder. So no, this is not a taper. We will have a separate video showing how to program for tapers as well. So we can push finish and save. And we have now successfully programmed that toolpath. And if we go down here, you can see the toolpath is now in our parts toolpath ready to be generated as G-code. So if we go over here and say generate G-code, that successfully places the surfacing cutter in tool number 1. And there you go. This whole sequence right there is what will actually turn the stock round from a 2 3/4 inch square section with those corners swinging all the way down to a 2.5 inch diameter section, starting at 4 and ending at 14. Okay, so let's save out this G code. In CeCam Pro training, and we're going to call this the turning round sample G code. There you go, G code, and save. So let's go to the machine and see what the cutting results actually do to this part. When the cutter is first approaching the material, you'll notice that it stops again at this diameter of where the corners are swinging, and from there it's actually going to cut down a certain amount. From the CeCam Pro software, one of the fields said it was going to be taking 1/4 of an inch per pass. While it's plunging into the material while rotating, it's making sure that it's climb milling the exposed corners to help prevent tear out during the machining process. After plunging deep enough for the first pass, it does a 360-degree rotation to square off those edges, and then it shifts about 40% of the diameter of the cutter and machines down the length of the turning center while rotating. The reason it shifts off-center is so that the cut is swinging with the grain of the material instead of cross-grain cuts. This gives us a better finish. Another default parameter that was in CeCam Pro is the distance the cutter is traveling per rotation down the length of the stock. In our roughing pass, this is 3/8 of an inch per rotation so that we can quickly remove the material. Once it reaches the end position of our turning round section, it squares off the corners once again, but rotating in the opposite direction to again ensure that we're not tearing out the corners on that opposite square face. The surfacing cutter will then repeat this process until it gets to our final diameter of 2.5 inches. One of the programming advantages that CeCam Pro does versus Conversational CAM Essentials is that the cutter will simply reverse the process going back and forth from left to right and right to left without having to lift the cutter out of the material to reposition for the next pass. This helps speed up the process and reduces any air time. Now the finish pass is going to repeat the exact same process, but it has a slightly different step over. The default step over in Conversational CAM Pro is 1/8 of an inch for the finish pass. This is to ensure a nice smooth finish down the entire length of this turning. All the cutting advantages that were explained here are automatically built into CeCam Pro and will be applied to every turning round toolpath. We can see how the cutter, using the advantage of the shape, is able to quickly machine the entire surface flat but around a cylinder circumference so that we get a turn diameter down the length of our spindle. You should now have a good understanding of what the turning round toolpath is and how the cutter approaches the material for any length of turning round section or diameter. Now, these types of videos generate a lot of different questions. I recommend you take advantage of 2 resources to answer your questions. First is head on over to our website at legacywoodworking.com. There you'll find all the different product information, additional cutting demonstrations, and much more. The second resource I recommend doing is actually getting in contact with one of our CNC experts. You can call them at 801-491-0010. They will be happy to answer any of your questions, put on software or cutting demonstrations with the machines, and point you to additional resources, again, to fulfill your needs. Now, if you'd like to just simply watch more videos, I don't blame you. Just click right over there. I think we all know what to do. If you want to be notified of future videos, just click that button down below, and don't hesitate to give us a like if you liked what you saw. As always, thanks for watching, and remember, Legacy solves more woodworking problems and allows you to say yes to more opportunities than any other CNC manufacturer in the industry.